Children, it is a continuation of the discussion about the basic concepts, formulae, hints of the chapters of the mathematics to score maximum in multiple choice questions. Now let us discuss about the chapter triangles, and that is about the triangle definition, congruency of triangles, similarity of triangles, basic proportionality theorem, converse of the basic proportionality theorem, and also about the criterion of similarity of triangles, and about the Pythagoras theorem and converse of the Pythagoras theorem. You know what is triangle, and also different types of triangles. Triangle is a closed plane figure bounded by three line segments, and triangle is having three vertices, three sides and three angles. Different types of triangles are also there. Then what are the types of triangles? Types of triangles can be named in two ways. One is based on the angles and the other is based on sides. Based on angles, you can name them right triangle, obtuse triangle, acute triangle. So what do you mean by right triangle? Triangle which has one angle equal to 90 degree. Triangle in which one angle is equals to 90 degrees is called right triangle. Obtuse triangle, triangle in which one angle is obtuse angle and the other two angles are acute angles. Acute triangle means all the angles are acute angles. The triangle in which all the angles are acute angle is called acute angle triangle or acute triangle. Now the types of triangles based on sides. How you can name based on sides? Scalene triangle in which all the three sides are unequal. Isosceles triangle, the triangle in which two sides are equal. Equilateral triangle, triangle in which all three sides are equal. Here all sides are unequal. Here two sides are equal. Here all sides are equal. So in scalene triangles all sides are unequal. In isosceles triangle two sides are equal. In equilateral triangle all the three sides are equal. And also you learnt about the inequalities in triangle. In triangle, opposite to the angle opposite to the longer side is larger and the side opposite to the larger angle is larger. The sum of any two sides of triangle is greater than the third side. Here if you consider a triangle ABC and the side which is opposite to the greater angle is greater and the side which is opposite to the greater side is greater. Angle opposite to the greater side is greater and side opposite to the greater angle is greater. So they in a triangle angle opposite to longer side is larger and side opposite to larger angle is larger. And also sum of any two sides is greater than the third side. That is, if you take sum of these two, that is greater than this side. If you take sum of these two, this is greater than this side. If you take sum of these two, that is greater than this side. Sum of any two sides is greater than the third side. Sum of any two sides is greater than the third side. That is about the inequalities. Now let us discuss about the congruence or congruent figures. Two figures are said to be congruent if their corresponding parts are equal. So two angles are congruent if they are equal. Two circles are congruent if they have equal radii. Two squares are congruent if the sides are equal. Like this way, two geometric figures are said to be congruent if they are exactly same size and same shape. If you kept one on the other, they coincides with each other. So they are the congruent figures. Now triangle congruence, congruency of triangles. When two triangles are said to be congruent, if three sides and three angles of one triangle is congruent to the corresponding sides and angles of the other. So you take one example here. If you take the triangle ABC and triangle DF, if AB is equals to DE and BC is equals to EF and AC is equals to DF. And also angle A is equals to angle D, angle B is equals to angle E, and angle C is equals to angle F. Then these two triangles are congruent. Here corresponding sides are equal. AB equals DE, BC equals EF, and AC equals DF. Corresponding angles are equal. A equals D, B equals E, and C equals F. So you know the symbol of congruence. What is the symbol of congruence? Symbol of congruence is these three lines or this one. You know it. And the above 6 equalities are between the corresponding parts of the two congruent triangles, and normally you can say CPCT, corresponding parts of congruent triangles. So here we should keep the letters in correct order on both the sides. Here you know that AB equals DE, BC equals EF, AC equals DE. So here you know that corresponding parts of congruent means you must write the corresponding parts which are equal. Also you learnt about the congruence rule. There are SAS congruence rule, ASA congruence rule, AAS congruence rule, SSS congruence rule, RHS congruence rule. So SAS congruence rule, side angle side congruence. Two triangles are congruent if the two sides and included angle of one triangle is equal to the two sides and included angle. So as it is an exam, there is no need of proof. So if you take these two triangle ABC and triangle DF, here AB equals DE and BC equals EF, and the included side of the included angle of the sides AB and BC is angle B. Similarly, the included angle of the sides DE and EF is E. So if they are equal, if here you can take in triangle ABC and triangle DEF, if AB equals DE, AB equals DE, BC equals EF, BC equals EF, and angle B equals angle E, then what? Triangle ABC is congruent to triangle DEF. Triangle ABC is congruent to triangle DEF, that you can write here. Next about the ASA congruence rule, angle side angle. So how you can define it? Two triangles are congruent if the here two angles and the included side of one triangle. Two angles and the included side of one triangle is equals to the corresponding angle and side. So if you take this two triangle, now here you have to take two angles. So you take, if B equals E and C equals F, then BC must be equals to EF. Here BC equals EF, angle B equals angle E, angle C equal angle F. Here common side is there and two angles. So you can say that two angles and included side. Two angles and included side are equal here. Then you can say that triangle ABC is congruent to triangle DEF. That is ASA congruence rule. Then one more congruence rule, AAS, angle side. Here two angles and one side of one triangle are equals to the two angles and one side of the other triangle. Two triangles are congruent if the any two pair of angles and any side of one triangle is equals to the corresponding angles and sides. So if you take these two triangles, angle ABC and angle DEF, you can name here BC equals EF, angle A equals angle D you can take, and angle C equals angle F. Any pair of angles you can take. Then you can say that triangle ABC is congruent to triangle DEF. And also you learnt about the SSS congruence rule. Here 3 sides of one triangle and 3 sides of the other triangle. Two triangles are congruent if the 3 sides of one triangle is equals to the 3 sides of the other. So if you take these two triangles, triangle ABC and triangle DEF, take AB equals DE, BC equals EF and AC equals DF. BC equals EF, AB equals DE and DF equals AC. Then triangle ABC is congruent to triangle DEF. That is about the SSS congruence rule. Next let us take the RHS congruence rule. That is right angle hypotenuse side. So two right triangles are congruent if the hypotenuse and a side of one triangle are equal to corresponding hypotenuse and side of the another. Here first they are right angle triangle. So here if you take these two triangles, here angle B is right angle, angle E is right angle. Then when they becomes congruent, if hypotenuse, that is AC equals DF. Hypotenuse means the side opposite to the right angle is called the hypotenuse. AC equals DF and any one other side. So here you take BC equals EF or AB equals DE. Then these two triangles becomes congruent. Hypotenuse and the side of a triangle are correspondingly equal to the hypotenuse and the side of a triangle. Now let us come to the similar figures. You know what are similar figures? Two figures having same shape are called similar figures. Consider these two circles. These two circles are similar figures. Similarly, here if you observe this rectangle and this rectangle, they are similar figures. Squares, these two squares are similar figures and these two right angle triangles are similar figures. And also you can observe that the congruent figures are always similar. Congruent figures are always similar because they are having same shape. They are having same shape. All congruent figures are similar figures, but similar figures may not be congruent. Similar figures may not be congruent. Therefore, you can say that two circles are always similar. Two circles are always similar because they are having same shape. Two squares are always similar because they are having same shape. Two equilateral triangles are always similar because they are having same shape. And two regular polygons having same number of sides are always similar because they are having same shape. So you can conclude that two polygons having same number of sides are similar if there are two conditions. First condition, their corresponding angles are equal, means they are equiangular. Their corresponding angles are equal. And also if their corresponding sides are proportional. If their corresponding sides are in same ratio. If the corresponding sides are in the same ratio, means if their corresponding sides are proportional. So these are the two conditions for the similarity of two polygons. Two polygons having same number of sides are similar if their corresponding angles are equal, means if they are equiangular, and if their corresponding sides are proportional, means the ratio of the corresponding sides are same. These are the two conditions. Same conditions holds good for the similarity of triangles also. So when two triangles are said to be similar, means they are having same number of sides, 3. According to this condition, you can conclude that all equilateral triangles are similar because they are equiangular and their sides also you will get the same ratio. The sides are in the same ratio. Similarly, all squares are similar. All squares are similar and all regular polygons are similar. You know that equilateral triangle is a regular polygon, square is a regular polygon. Similarly, you can have regular pentagon, regular hexagons, etc. So, all regular pentagons are similar, all regular hexagons are similar. That is because the condition two polygons having same number of sides. You can compare triangle with the triangle, quadrilateral with the quadrilateral, pentagon with the pentagon, etc. So the condition is first one is there, that is same number of sides. And if they are having same number of sides, they must hold two conditions must hold. That is, they must be equiangular and their sides must be in the same ratio. The ratio of their corresponding sides must be same. So you write that two triangles are similar if their corresponding angles are equal. They are equiangular. Their corresponding sides are proportional. Therefore, you note down two figures having the same shape but not necessarily the same size are called similar figures. All the congruent figures are similar, but the converse is not true. Similar figures may be congruent or may not be congruent, but the congruent figures are always similar. Now let us take the basic proportionality theorem and its converse. Then that basic proportionality theorem is also called Thales theorem. There may be question in the question paper to recognize the basic proportionality theorem or converse of basic proportionality theorem. It is also called Thales theorem. So there may be question to recognize the Thales theorem or also converse of Thales theorem. What is the statement of the basic proportionality theorem? If a line is drawn parallel to one side of a triangle to intersect the other two sides in the distinct point, then the other two sides are divided in the same ratio. And its converse. What is the converse of BPT? That is the converse of Thales theorem. If a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. So you can, in the form of figure also it may be there. So in the figure what will be given? Triangle will be given and the line parallel to the side of a triangle is given. It may be parallel to any side, like this way, or like this way, or like this way. If D is parallel to BC, then ratio becomes AD by DB is equals to AE by EC. Or if D is parallel to AC, then the ratio will be what? BD by AD equals BE by EC. Also AD by BD is equals to BE by EC. In this way, according to the parallel line, the ratio changes. You must know the method of writing the ratio also. If this is parallel to this one, then the ratio becomes this by this equals this by this. That is CD by AD is equals to CE by BE, or AD by CD is equals to BE by EC. Next, if a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. Here, this is the converse of the Thales theorem. So what will be given? The ratio will be given. ABC, consider DE. If AD by, if the ratios are same, if AD by BD equals AE by EC, then this DC is parallel to, DE is parallel to BC. Here this by this equals this by this will be given. Then what becomes? DE parallel to BC. That is the converse of the Thales theorem. Now let us see the criterion for similarity. Which are the criterion for similarity? There are three criterion for similarity. First one is the AA similarity criterion. Second one SSS similarity criterion. Third one SAS similarity criterion. Then according to AAS similarity criterion, if you take two triangles, if they are equiangular, they are similar. That is the AA similarity criterion. So in triangle ABC, if A equals angle A equals angle D, angle B equals angle E, angle C equals angle F. Or you can take like this way also. If B equals angle D and A equals angle E, C equals angle F also you can take. So they are equiangular. If they are equiangular, then you can say that they are similar. Next, SSS similarity criterion. That is, if the corresponding sides are in the same ratio, that is AB by PQ equals BC by QR equals AC by PR. If the corresponding sides are proportional, that is about the ratio of the corresponding sides, SSS similarity criterion says, and SAS similarity criterion says here if two sides are in the same ratio, two pairs of sides, that is if DE by LM equals EM by MN, you can take any two pairs LM by NM, LM by MN, their included angle, and angle E equals angle M, then it is called SAS similarity criteria. Two sides and their included side you have to take. If two sides are in same proportion and their included angles are equal, if you take these two sides, you must take this angle, and if you take these two sides, you must take this angle. Then if they are equal, that angles are equal and their corresponding sides, the sides are in the same proportion, then you can say that is the SAS similarity criterion. There may be question in your question paper to recognize AA similarity criteria or SSS or SAS. Here that you have to make AA, you can make out easily because three pairs of corresponding angles will be there, means there becomes the equiangular. SSS also the ratio here we have to take. In SAS, two sides and their included angle must be taken. That is about the criterion for similarity of triangle. Now you take the first one, AA similarity criterion. Angle similarity. That is, two triangles are similar if corresponding angles are equal. So if you take the figure here, if you take angle A equals angle D, so you take the figure of the triangle ABC and triangle ABE. Now if you take this is ABC, this is DEF. Now angle A equals angle D, angle B equals angle E, angle C equals angle F. So their corresponding sides becomes proportional. If they are equiangular, their corresponding sides are proportional and they are similar. Next side, SSS similarity. So two triangles are similar if the sides of one triangle is proportional to the sides of the other triangle, means their sides are in same proportion. So if AB by BE is equals to BC by EF is equals to AC by DF in these two triangles, then you can have the equiangular, means they are similar. Triangle ABC and triangle DF are similar. If one condition holds, then other holds naturally. If they are equiangular, then their corresponding sides becomes proportional. If the corresponding sides becomes proportional, then they becomes equiangular. So if one condition holds, other naturally holds. So here you can say that if the sides of the two triangles are in proportion, are in same proportion, then the two triangles are similar, means they are equiangular. So if AAA holds, SSS holds automatically. If SSS holds, AAA holds automatically. Now about the SAS similarity criterion. Two triangles are similar if one angle of a triangle is equals to angle of the other triangle and the sides included, that is proportional. So if you take triangle ABC and triangle DEF, here AB by DE is equals to AC by DF. AB by DE is equals to AC by DF. So which angles we have to take? Angle A equals angle D. So here this is there, means you can say that triangle ABC is similar to triangle DEF. That is about the SAS similarity criteria. Now about the area of similar triangles. If the two triangles ABC and EDF are similar, means if triangle ABC is similar to triangle DEF, then area of triangle ABC by area of triangle DEF equals AB by DE whole square or BC by EF whole square or AC by DF whole square. If you consider the similar triangles, if these two are similar triangles, consider this is the triangle ABC, this is a triangle DEF. If triangle ABC is similar to triangle DEF, then here what you can take, area of triangle ABC by area of triangle DEF equals what? AB by DE whole square or BC by EF whole square or AC by DF whole square. You can also write AB square by DE square or that is equals to BC square by EF square. Also you can take AC square by DF square. So here area of triangles, area of similar triangles are proportional to the squares on their corresponding sides. Here AB and DE are the pair of corresponding sides, BC and EF are the pair of corresponding sides, and AC and DF are the corresponding sides. Then one more point you must know, if a perpendicular is drawn from the vertex of the right angle of a right triangle to the hypotenuse, then the triangle on both the sides of the perpendicular are similar to the whole triangle and also to each other. Here consider a right angle triangle. ABC, which is right angled at B. If a perpendicular is drawn from the vertex of the right angle, here which is the right angle vertex? Angle B. If the perpendicular is drawn from the vertex of the right angle to the hypotenuse, you know that which is the hypotenuse here? AC is the hypotenuse because it is opposite to the right angle. Now consider BD is the perpendicular drawn from the right angle vertex to the hypotenuse. So here what they say is triangle on both the sides of the perpendicular are similar and also similar to the whole triangle. So the triangles on both the sides of the perpendicular are similar, means both the triangles on both the sides of the perpendicular are triangle ABD and triangle CBD. So you can say that triangle ABD is similar to triangle DBC. Before that you write, in right angle triangle ABC, angle B equals 90 degree and BD perpendicular to AC. Then what? The two triangles formed on both the sides of the side of a line BD, both the side of the perpendicular is. So the two triangle formed on both the sides of the perpendicular triangle ABD similar to triangle ABD similar to triangle BCD similar to triangle, you take ACB. Here all the three are right angle triangle and they are similar. And also you can have one more relation. What is that relation? Here AB square is equals to AC into AD. You write that AB square is equals to AC into AD. Here you observe AB square is equals to AC into AD. AC into AD. And next relation you can have, what is that? BC square. BC square is equals to again AC into CD. AC into CD. If you observe that BC square is equals to AC into CD. That is the relation got here. Next one. BD square is equals to this AD into CD. AD into CD. Here you observe BD square is equals to AD into CD. AD into CD. If right angle triangle is given, if perpendicular is drawn from the vertex to the hypotenuse, you will get these important relation and also these relation, which are important to solve many problems. So you keep in your mind while solving the multiple choice question. Now let us discuss about one more important point in this triangle chapter, that is the Pythagoras theorem. Then what is the statement of the Pythagoras theorem? In right triangle, the square of the hypotenuse is equals to the sum of the squares of the other two sides. That is the statement of the Pythagoras theorem. So here hypotenuse square equals base square plus perpendicular square. Now you consider the right angle triangle. Here which may be base or it may be this perpendicular. Now if you take this right angle triangle, you take in the right angle triangle ABC, angle B equals 90 degree. Any angle may be 90 degree and the side opposite to it is the hypotenuse. So square on the hypotenuse is AC square equals sum of the squares on the other two sides. So you take that is AB square plus BC square. AB square plus BC square. That is square of the hypotenuse is equals to sum of the squares on the other two sides. That is the statement of the Pythagoras theorem. And there may be multiple choice questions to recognize the Pythagoras theorem. 4 options will be given and you may try to recognize the Pythagoras theorem with this basic knowledge. Now let us take the converse of Pythagoras theorem. Then what is this converse of Pythagoras theorem? In a triangle, if square of one side is equals to the sum of the squares of the other two sides, then the angle opposite to the first side is a right angle, or those two sides contain right angle. So let us have in triangle ABC, if square of one side, that is if AC square equals AB square plus BC square, then angle ABC, this is the angle opposite to AC square, or this is the angle between the sides AB and BC. So you can have angle B equals, then angle B equals 90 degree. That is the converse of the Pythagoras theorem. That is the statement of the converse of the Pythagoras theorem. So in a triangle, square of one side is equals to sum of the squares of other two sides. Then those two sides contain right angle, or the angle opposite to the first side is right angle. Both are same here. So that is the converse of Pythagoras theorem. And here we know that on the base of this theorem, triplets of three numbers will be given. Triplets of numbers will be given and question will be there. Verify that whether they forms the right angle triangle or not. In that case, what you have to do? You have to take the square of all the numbers. And if the square of one number is equals to the sum of the squares of other two numbers, then you can say that they are the sides of the right angle triangle. For example, if you take 3, 4, 5. Now you take the square of 3 is 9. Square of 9 is 16. Square of 5 is 25. If you add these two, you will get 25. Therefore, you can say that yes, square of one side is equals to sum of the squares of the other two sides. So you will get a right angle triangle. So which becomes the hypotenuse here. The side with the length 5 cm becomes the hypotenuse. Similarly, you can give many examples. 6, 8, 10. See here, 6 square is 36, 8 square is 64, 10 square is 100. So I told that you must practice, you must know the squares of a number. If you know the squares of a number, you can choose the correct answer quickly. So here 6 square is 36, 8 square is 64, and this 10 square is 100. Now if you add these two, 36 plus 64 is equals to 100. So here these three sides with this measurement forms the right angle, and which becomes the hypotenuse. The side with the length 10 centimeter or 10 measurement becomes the hypotenuse. In this way you can give many sets of Pythagorean triplets. So you can give here 12, 16, 20. 12 square is 144 and 16 square 256 and 20 square 400. Add these two. So you will get 6 plus 4 10, 5 plus 4 9 plus 1 10, and also 2 plus 1 3 400 you will get, which is equals to this one. Similarly, these are also the sides of the sides of the right angle triangle. So they are the Pythagorean triplets. So that completes the chapter triangle. You go through the important points, formulae and statement of the theorems and learn perfectly, and also you must know the square roots. So let us discuss the next chapters in the next video.